Welcome back and Happy New Year to 2026, isn't it? Woo! Hope everyone had a good ride over the New Year's and a nice Christmas. So we want to get started with, next to the talks that we have up here, we want to get started with a special guest today, Dan from the Erlang ecosystem, and give us a little bit of an ecosystem update for this year and maybe an outlook for the rest of this year. So I'm really excited about that. And then we will go back to our normal program. Also, what we want to do is, usually like what you see is we have these lightning talks. And so if you have something at the top of your head that you would like to talk about, then you have the chance to put that down. And I will put some white paper here in a bit. So if you have an idea that you want to talk about, just put it there. And then at the end, you can spend 5 minutes on that. Also, what I think is usually appreciated if you have like something I learned today in a short form, or something unusual you learned about Elixir that you didn't know about before, or about the Beam or about Erlang, just share that with everyone. I think it's usually a great idea. With that said, Dan, you want to take us through the ecosystem updates?
Yeah, sure. Hello, it's great to be here, and Happy New Year. So I just wanted to say a few words about what we're working on at the foundation. We're starting off 2026 with having submitted, having in process a few grants for working on core security things. So there's also, you may know from last year, there was also the Kickstarter for Rebar and upgrading Rebar, so that's going to start this year as well. We've submitted some other grants for security work with another government to do work on, let's see, wait a second, which one is this? There's work on Hex, there's work on software bill of materials. So we're trying to get the ecosystem better situated, or a better stance on the kind of core security things that we all need to sort of continue to move forward and be qualified for certain kinds of projects, which will all call for these kinds of things, but also we'll be less vulnerable to the kinds of attacks that we're seeing in other ecosystems, which you may have heard about or know something about. A few of us are going to be at FOSDEM. Is anyone here going to FOSDEM? Great. So we're... Get vaccinated. Get vaccinated. Very good. Good advice. Good. Yeah. Good advice. Masks may be appropriate. So one of the things that we're doing a lot of is getting involved in the regulatory space, because there are a lot of discussions and work that are happening in Europe around open source and making it sustainable. So who here does any work on open source projects within the ecosystem? Anyone? No? Whoop. One back there? Okay. So we all rely on open source. I mean, Elixir itself is open source. Erlang is open source. All the hex packages are open source, and that is effectively our supply chain. So we are getting involved with ways to make that supply chain more sustainable. And if you haven't heard of the CRA, has everyone heard of the CRA, knows what the CRA is? So the Cyber Resiliency Act, which is legislation that was passed in Europe, and it's basically structured to create a sustainable loop for manufacturers to sustain their supply chain, which a lot of it is open source. And ultimately, what we're hoping is that through, I think it's supposed to be in full force in September of 27, but there are a lot of steps that have to happen before then. And what this means is that a manufacturer that's creating a product with digital elements will be responsible for proving that they are supporting their supply chain. So that should create a funding stream for open source packages, open source maintainers, and will hopefully yield a more generally sustainable ecosystem. So there are lots of companies that are using Elixir or using Erlang, and we are talking with them and basically trying to get everyone on board so they know what's coming and what that actually means. But also, the more people, the more companies that get involved in supporting the ecosystem, the easier it is for everyone. So right now, the number of supporters is relatively small, and we're hoping that as that grows, we'll be able to not only make the ecosystem more sustainable, but also be able to cover things that we are not that strong in at the moment. So there are a variety of interfaces that we don't have very good support on, or they're lightly maintained, and we want to elevate those so that we can qualify for doing work that currently is hard. So I'm sure, you know, like when you start a project, you have to look at like what are the supported either API libraries or other things, and whether you'll have a hard time or an easy time, how much you'll have to write in order to, you know, get a project done. So we're hoping to pick the right things so that we can get better support for the kinds of projects that people want to write. So the CRA is an integral part of trying to like close the loop on support for open source. So the foundation is very active in this space. So regulatory, basically talking to politicians and NGOs and going to things like FOSDEM, which seems like just going to a conference, but there are a lot of events where this is a very like intense topic, and trying to figure out how do we tie all the things together. So that's sort of the big topic for 2026, and we'll continue doing that. And then there's ElixirConf, which you may know is late April in Malaga, Spain. And we're hoping, or I'm hoping, to organize a side event like we did for CodeBeam that kind of was more community oriented. So there'll be some announcement around it if we can find the space and some other things. So look for that.
Before?
That is an open question. I think it may be better the day after, because I think we'll also have more things to potentially talk about. But we want to try to get that part sorted out early enough that people can make appropriate travel arrangements, because we don't want to wait. I think that was one of the limiting factors with the events that we had after CodeBeam, is that we kind of got our act together a bit late for people to incorporate that. Yeah. So you may also have heard that Lars Wikman has announced that there'll be another Goatmeyer, which we're all very excited about. Maybe you've heard about, or the videos are all up, so it was a pretty special experience. And I think maybe that's enough of me droning on, unless anyone has any questions about any of these things. Okay.
Thank you so much, Dan.
Thank you.
I actually have a question for that. Like, who's planning to go in April to the Elixir Conf? And do you want to, Leonard, do you want to get set up while I'm talking for a second here? Who's planning to go to, some show of hands, yes? So there's some people here, not sure yet. When Dan said, like, we're planning, I thought he's not going to say side event. He said, I thought he's going to say, like, a community travel to Malaga or something. Like, how do we get together from Berlin to there? But we're going to have next month an event, a normal meetup again here. And then March, we're going to have the BobConf team up with the Clojure team probably again, like we did in the previous years. That was really fun. And so there's the kind of functional conference coming to Berlin, and we're going to meet with these guys and with the Clojure folks and talk about all things functional, and also have an Elixir talk there. And the following month then is the Elixir conference month. So it might be that we don't have a meetup yet. Let's see how many people are still in Berlin then. So if there's enough here, I'm not going to be here, I'm going to be there. If enough are here, we will also have a meetup. Otherwise, we'll skip it. And with that, let's go back to the program. And Leonard is going to tell us about AIs without neural networks and what the state of the art is there. That's Leonard. Thanks.
Yeah, thank you. Thank you very much. So yeah, I'm going to be talking a bit about different approaches to AI other than large artificial neural networks. This is an ongoing research project. So I'm a PhD student at the Center of Analysis and Design of Intelligent Agents at Reykjavik University in Iceland. It's one of the very few places where other approaches other than connectionists, so not neural networks, are being researched. And yeah, my background is not from computer science. I came from biology a long time ago. I have no formal education in computer science, but a bunch of stuff in robotics. And when I, at some point, reached the field of autonomous robots, I realized that autonomy is more of a flashy word that we use nowadays. And true autonomy, as I would understand it, is really, really far away. And even nowadays, with neural networks everywhere, we still see a bunch of issues. It's not really working well. And I was interested in building robots that can actually act and live in this world, and autonomously achieve stuff that we want them to do. Which is quite different to a particular message sent and wanting a prompt sent somewhere and wanting a singular answer back. It is more about state management, about continuous existence of these things that need to integrate more and more information over time. So what I will be talking about is very, very little about ANNs, just super, super short, one slide, a moment about it. But what I really want to talk about is online learning, lifelong learning, reasoning-based learning. So how can we use and apply logic to problems so that we can have explanations and chains of reasoning and reasons for the output that these systems give. And yeah, the cumulative integration of knowledge. And then in the end, I'm working on this in Elixir, and that's why I'm here. I'm going to be just talking a bit about that. So this is from a perspective of a roboticist, not from a computer scientist, which, I hope that everything will be understandable, what I'm talking about. Yeah, what I'm not talking about is any language processing, any large language models, or any ANNs, except to make a point about something, right? Disclaimer, this is a research project. It's been going on for a few years now, but nevertheless, the work on the Elixir implementation has only started a few months ago. So don't expect too much. It's heavy work in progress, but I'm trying to get across some fundamental principles, some ideas behind this whole thing, and why I believe that Elixir is a brilliant language to do AI if you're just doing the right sort of AI. Something to think about, this is Megafragment Memory PN. It's a WASP. This is the size of this thing. It's as large as an amoeba. It has a brain size of about 52,000 micrometers cubed. It's tiny, it's extremely small, and nevertheless it can fly, it can eat, it can mate, it can live in this world. We do not need trillions of hyperparameters to produce things that can actually act in this world autonomously and achieve goals, right? Apparently we need 7,400 neurons. I think it has been completely mapped, the whole brain and everything, right? Because it's so little that you can actually do this.
Mapped as in one totally understands how it works, or?
No, just mapped, which neurons are there, how they are connected. How it works is a really, really difficult problem from the biological side, right? I studied insect brains a few years back, and just to model a singular motor neuron of a fruit fly maggot is a full PhD, right? This is with all the channels, with all the calcium channels and ions and everything that you need to model in there. We don't really understand how they work, but we can see how they can work together. Neural networks, this is my very short intro. We have an input layer where we put something in, an embedding space, an image, and some sort of data set. Then we have a bunch of hidden layers that usually do some magic by approximating some highly nonlinear function from the input to some ground truth output that was trained over some time. And then in the output layer, we have, after this magic is applied, we have the wanted result, or at least an approximation of the wanted result, right? During training, this goes back and forth. We compare the outputted truth to the output to our ground truth output of labels or something like that. And then the error is computed, how far off this was, and then it is backpropagated through the system. And that is how these neurons are being adjusted, how these hyperparameters are being computed. And then once it's fixed, it goes into deployment, and there's no change to it anymore. And we throw something in the input, and we get something out at the output. So why I don't like this a lot, in some cases, where does the output come from? What are the reasons why this output was created? Is the output correct? What happens, if we don't have a ground truth for something? How can we know whether the output is correct or not? How is this highly nonlinear function approximated? What is in there, We have billions or even trillions of neurons or hyperparameters that we have no idea what is happening there anymore. Just as a fun little example, the Adam optimizer, maybe you guys have heard of it. It is probably the most used optimizer for backpropagation in neural networks. It was wrong. 6 years after it was first published, the proof of it, somebody realized it was wrong. It was at the time the most cited paper in the computer science world. That's already a few years back. There was a mistake in the proof, right? And nobody ever checked it. And
which proof is that?
I think it's called the Adam proof, Adam optimizer, the proof of how to optimize the sigmoid function that is a hyperparameter. Right, it has been fixed since then, and it worked very well, and the libraries took over the fix. So if you're using any sort of PyTorch or something, it's the correct Adam optimizer in there. As far as I know, this was wrong for about 6 years because nobody has an idea, right? It is purely this, as long as the output is correct, we believe that this thing is working the way that we want it to. But what happens if something novel appears? What if something happens that has not been in the training data? Well, the system will produce an output. With some luck, it's going to be a good output. With, bad luck, it's just going to be completely disastrous. So with what we see right now, I would say strap in for the ride because we don't know what's going to happen in these systems. So the key problem is really nobody understands really what is going on in there. This includes the AI itself. It has no understanding about its inner workings. And it includes us. We have no understanding about it. It is working good. Don't get me wrong. I use AI on an everyday, like large language models every day, and I love them as a tool. But for robots, for autonomous cars, for maybe household robots, stuff that is right next to you, you don't want it to suddenly jank the steering wheel to the left because some weird output was created. If I get a text back which is off, I can read it, I can understand it, and I can fix it, right? But if we want to build robots, I don't know if it's a good idea. So what can we do instead? Well, make this whole mess explicit, make it transparent, and make it understandable. Right? Super easy. I'm going to skip the next few slides because I'm taking way longer than I expected. But yeah, what I would be talking here about is that, you know, the idea was to have systems that learn on the go. And, you know, we learn differently. We don't learn that stochastically. Here I have an example, Agent 57 outperforming the Atari human benchmark. So playing Atari games, right? Maybe all of you know them, or it could be PS games, Xbox games, whatever. This graph here, I don't know if you can see it really well, shows how good it gets, you know, over time. And I did a little block here. So this is the number of frames, they call it. So how many frames the system played in Atari. What do you guess if you look at, you know, the stabilization here after 1 frame times something? What's this number below this square? How many tries does an AI system need, a reinforcement learner need, to learn playing Atari games? Any estimation? 10,000. That's, you know, to the power of 10. Yeah, I don't know. I think we learn a bit differently. I didn't need millions or billions of tries to learn an Atari game. So what do we need instead, or what I believe we need instead, is reasoning-based learning, right? Learning that happens by me understanding how the world functions, by reason about logical conclusions, and by making my mind up about, you know, what is actually happening in this world. Now, the problem here is a bit, I'm a human. I have common sense. I have been growing into, you know, myself for 33 years, and I have a bunch of stuff that I've learned. But if we look at the very, very few first weeks or months of a baby, there is no language. There is no abstract reasoning there yet. So this is more what I'm aiming at in this talk here. So what we want is experience-based learning, continuous integration of new knowledge that we can accumulate over time and integrate into our knowledge base. So if I make a novel experience, I can, you know, reuse it later on, and planning through reasoning. So I get a plan before I know what I want to do. So to summarize what we want, with we, I mean the team at Reykjavik University and myself, we want online lifelong learners capable of reasoning through causal relations. So what causes what in this world? What is the cause? What is the effect? And how can we manipulate this world in such a way that it will transform into the goal state that we set the system, right? I wanted to clean the dishes, so it must come up with a plan how to transform the world such that the dishes are clean, right? From there, it can reason about what does it need to do in this world in order to achieve this transformation of, you know, a world where my dishes are clean. This includes self-programming, so systems that only build kind of scaffolding around their own structures that can be adjustable, that can be bound, that can be, you know, from variable description to actual value assignment, everything in there. We want autonomous knowledge acquisition, knowledge integration, plan generation, plan evaluation, and then in the end, plan execution. So, you know, the car should drive in the end, or the thing should clean my dishes in the end. So that's the whole kind of background behind that. For that, we have developed, or, you know, my predecessors have developed the ERA architecture, autonomous empirical reasoning architecture. You can see it on openera.org. It's a reasoning-based system that uses data directly from sensor information rather than, you know, abstracted away into language. It uses direct data streams, and it represents its knowledge in what we call tiny wee models. They are extremely small, little, processes or little things that map an input to an output. So for simplification, at this point I will use human language, what I mean with reasoning and what I mean with chaining, because that's what we're getting at now. When there's a motor in the joint, the system can execute the move joint command. Afterwards, the joint angle will have changed, right? This is a statement that we can think about as one of these models. When the earth is dry, the system can execute the water plant command. Afterwards, the earth will be wet. If the earth is wet, plants will grow. When plants will grow, they carry fruit. When plants carry fruit, I can get fruit, right? Now we have chaining. We have a bunch of these models, each individually, and we can plug them together and build chains of reasoning that in the end give me a plan. I want to have fruit. What should I do now? Well, water the earth. In a more system-like description, this would be something like this. So we have a command for some motor X that has the name change angle of a delta of alpha of this angle. We have some context or template arguments. So the motor has an angle before, right? And now we apply this change angle thing. And then afterwards, we will have alpha plus a delta as the output, right? So we always have a context. We have a command or some sort of cause. And we have an effect that will be produced by it. When we chain this together, we can talk about, hand is at a position X and an object is in position X. If that is the case, if that is the context that the system is placed in, then it can grab and then afterwards it will hold the object. But also something like, if I have a hand at some position X and I execute the move command, then the position will be X plus delta X. And now again, we can chain. If the hand is not at the same position as the object, we can analyze, I want to hold the object, so what do I need to do right now in order to do this? Here's a very short example of how this then looks in the error architecture. So it is moving around and it is moving to some objects and picking them up. This is from my colleague who did work on analogy making. So the system is drawing some analogies. Right now it learned how to pick up two different things, and now it's trying out to pick up the other thing. It first expects, because it has the same color, that the same mechanism as before works, which was just grabbing without rotating first. It realizes it's wrong, adjusts its knowledge base, and realizes, okay, so the similarity is the shape of this thing, and adjusts then for the rotation. If it then moves to the next thing over there, it will draw the right conclusion that this is similar in shape as the sphere, and then immediately executes without trying to adjust for rotation. So this is all working. It's a massive, gigantic C++ code base. Can I move on? Has a central inference engine, so that means that there is one central thing that takes one rule after another and tries out whether they stick together, and if not, then it draws the next one. But what I want is a system that can grow in structure and integrate new information without this central inference engine. So without any central thing that actually does the reasoning, rather the reasoning should be distributed through the whole system. And well, how do we do this? Of course, with Elixir. As I said, these are super tiny models that represent an input and an output, and we chain them together. So why not use processes, Elixir processes, to represent these little models and have each and every one of these models be their own inference engine. So it gets input and it will produce its output. And then the structure itself, the connection of these processes, the messaging pipelines that are being built up between them, that is where the reasoning happens, right? So instead of searching for the rules, as soon as I experience a particular rule that matches something else, right? I try something out, I let this thing go and it falls down. Now I start to connect the two nodes in my network that says, one says letting go and the other one says falling down. Now I have integrated a stable connection between the two that can be reused and automatically produces the output without any sort of central engine that needs to collect anything anywhere. And yeah, my goal in the end is, something like, how can I build a system where the leg can walk without the brain thinking about it, right? So I want to have this as distributed as possible. And in the end, all that is happening is that a goal is propagated through the network, and each node is responsible for producing this particular output. So each node or model tries to reduce the error between the current state and the goal state, right? And that is just all that it is. It is just a chaining of a whole bunch of different of these models together. This then builds a reasoning graph that is, from goal all the way down to the commands that can be executed, to singular motor movements, and on the other side, from perception, so from the sensors inside. And then we have these models that keep track of, how the neighbors are and what their state is, send messages between different types, and spawn prediction monitors, and that is then where the learning happens. So prediction monitors are, I'm going to skip this as well, are producing a prediction once a command is executed, how the world will look like later on. And then when the new observation comes in, the prediction monitor checks whether the world actually looks the way that we expect it to. If not, produce new models, produce new causal chains. If it does, everything is working fine, and let's continue on with the movement, right? This is evaluated in a very, very, very high frequency. So in control theory, we're usually at 100 to 200 hertz, that these things must be updated and continuously, changing their inputs and adjusting commands. But the nice thing is that, a motor movement can be reduced down to 3 little Elixir processes that do the expected movement to actual, received observation. So yeah, the cost of running 3 Elixir gen servers is really not the problem here and can be evaluated very, very quickly. And yeah, this whole, in the end, it is kind of a recursive function from the goal that always calls itself all the way down to the effectrons or the command models that actually send out, voltage on a wire that moves a motor. And yeah, the end of this recursion is in the end at the actual effectors and the actual perceptors that sense and actuate in the world. So yeah, everything is distributed. Everything is based on the belief of the system. That was here the internal state estimator, so I don't use perception per se. I'm more using internal estimations of how the system believes that the state of the world is in right now. And I started it already, I hope. Just a very, very, very short demo. I said at the beginning it's just going to be a dot moving around on screen. So let me initialize this. Did it work? Looks good. So what the system has here, it's a 3D environment in this life book where we just simply have force-controlled movement, right? So the system can set a force on the movement of a point in 3D space, and it is supposed to learn from nothing how the differential equation of movement through acceleration works in this little environment setup. And what is happening, so in the beginning, I bootstrap the perceptron so that they can estimate the probability distribution of how the actual sensor data is distributed. Instead of using exact raw data, I'm using a bit of distribution bootstrapping so that we get a nice, Gaussian bell curve that we can approximate and use for reasoning. And now I can give it a goal. And when I now let it run for 500 steps, we can see it doing complete random stuff. It's supposed to go to 0.00. Right now you can see that that's starting to align now to the goal. It is starting to figure out, how all of this works. Often when it reaches somewhere around 0.00, it starts to behave really weirdly because it has created multiple hypotheses about how the control in this world could look like. And this we can see here in the observer, which I'm just going to be using here for a moment. So we have, now what's happening? So we have 2 different chains of reasoning. So this one here is the goal at the very top here. And then 2 different chains are going down. One is the assumption that we have velocity control. One is the assumption that we have force control. So this is just, approximating differential equations. The system has no idea how this all works, right? It starts with tabula rasa, with nothing about how this world behaves. So it creates hypotheses about how the control could influence the world that it is in. And in this case, it is producing 2 different hypotheses. One is, that you're controlling the velocity, and one is that the acceleration is controlled. And now if I give it a new goal, to be at position, for example, 15, minus 155. I played around with this earlier, so let's just use that. And we let it run for another 100 steps. So now I gave it a new goal that led to a rebinding of what the system is trying to achieve, right? So now it's trying to minimize the error between real observable and the internal estimation of how the world looks like. And then it immediately shoots out down towards -15, -155, right? As I said, this is a small example, but the general idea behind it, I hope, came across. Now, where this is all going, well, right now it is a point in 3D space, but what I'm working on right now is to transform this into actual movement of joints of robot arms. Right, so I hope that we can build a system that approximates the kinematics of a robot arm in an expressible way, because I can go in here, I can look at any of these models, and in there I can find something that is called a backward function or a forward function. That is the actual, this is just a quoted Elixir function that is evaluated on the fly when binding comes in. So when new variables are being sent into this node, it binds it inside the function. So before it was, a dollar value for easy pattern matching with ETS. And then afterwards it becomes an actual, 0.05 or something like that. And then there is an actual, linear equation that is being evaluated, or whatever equation you want to have, because it's just a quoted Elixir equation. You can do whatever you want there. And then, if we build systems like that, you can actually look in there and you can understand how the reasoning went through these systems. So I have a very small visualizer here where I can go and look at the actual messages that have been sent. So, of course, it's not working now. Oh, yeah, I was too quick on that. So if I jump to the start and just, go somewhere. I looked up some halfway good seeable example earlier. So let's go here. We can actually see how messages are being propagated through the system, how predictions lead to, in a second, the creation of, of prediction monitors. Those are those small things here. And then we can look at the prediction monitors in theory. Let me make this larger. And we can actually see what the system believes that these predictions should be, right? So I can look in the state and see the actual values that the system was working with, and can follow the whole equation system through that came to a decision. Yeah, sorry, this was a bit longer than I think I should have been talking about, but I'm just very excited about this whole stuff. And yeah, I hope that you didn't get too bored. And yeah, in the end, my message in this is we don't need to build Elixir around neural networks and try to force it through some sort of, numeric number crunching mechanism into building systems that can actually, use AI. Maybe, the Elixir way of doing things is actually a good way to approach AI as well, right? By distributing stuff, by making it into very, very small processes that can intercommunicate between each other and span up larger and larger networks that you can actually follow through and understand what is happening in there. And if errors ever are raised, it's just an output value that you can use for adjusting your models of how they work in this world. And yeah, this is kind of why I love this language and why I came to use it in this particular case, because as you can imagine, building this in C++ is a real mess. And here it is just something around, I think, 5,000 lines of code. I think that's it, that we will hopefully need to build all of these things. Yeah, thank you for having me.
Questions? Let's start up in front here.
There was a very hyped term back in the time, semantic web.
Yeah.
Do you see any relation?
I honestly have not too much idea about semantic net, but semantics, ontological networks, all that kind of stuff is very, very closely related to this. So there are some colleagues in other universities who are building on more symbolic kind of information. Rather, we are coming from robotics, others are coming from computer science, and in these in these symbolic representations, you can find these whole networks being grown. Nowadays, we call it knowledge graphs, right? But they are just semantic networks, and yeah, there's a whole bunch of research going on in that direction. But I really care about robots, so I'm doing this kind of stuff. I want to have an AI that actually cleans my house. I would love that.
Yeah, if you got one, send me one of those as well. Dan? Yeah.
Do you think that there's a direct connection between any form of intelligence and having a body?
Oh yeah, 100%. I'm a strong believer in the embodiment theory that agency and intelligence needs embodiment in this world, because I don't see a point how you can learn about the physical world that we are placed in without having any sort of embodiment. And I skipped over this, but this whole project is originally coming from kind of how to handle an embodiment. So again, I'm coming from robotics. This is kind of my thing, but how else would you learn about that this thing will fall down if I drop it, right? And build an understanding of causality of this world rather than just correlational data. For causality, you need to have interaction. You need to set something to some value, and that means you need to have an embodiment.
Mila?
The word that the robots are using these models, is it something that you teach one robot and then copy it, or you let every robot to have its own experience?
I don't see the point why the system couldn't just run on two robots. This is also an argument that I've been having with some fellow researchers. When does one system become two? These systems do not have any sort of compression that is necessary in order to bring information from A to B, right? What we are doing right now is in my brain have an idea of what I want to say. I'm compressing it into language. I'm sending it through sonic waves over there. You're taking it up and you're integrating it back into your conceptual space of how the world works. They don't need that, right? They can just send the data immediately. They can even send a whole node over there, right? A whole process. When does one system become two? Is it just, delay time, latency? If one is on the moon and one is on the Earth, are those now two systems because they take a lot of time before they can, share information? I don't know. But yeah, you could copy it over to some other thing. The problem is just, if you're using different motors, if you're using a different embodiment, then the system will need to learn about this embodiment from the beginning. So if you have a little vacuum robot and you have another thing that is a flying drone, it doesn't really make sense to share stuff between them, right? Because in this, every knowledge, all knowledge is built up from the very, very sensual experience of what it feels like to touch something, of how it is to move my arm, how this changes in my vision, All knowledge is built up from the embodiment to higher level abstraction and cognition.
Nice. One here?
For the dish cleaning task, how do you keep your robot from trashing your dirty dishes, going over to your neighbor, killing your neighbor, taking his clean dishes and handing you them over?
The same way that I get my kid not to do that.
Which is?
Teaching it not to do that. That's, we're always talking about these general systems as being, super dickheads and complete assholes and will kill everybody. We have general systems, general intelligences that are being created to the, millions and billions every year, which are just human children, right? They are all general intelligences. Of course, maybe not with the whole capabilities, but in the end, how do we teach them not to become, warmongering psychopaths? Yeah, by introducing them into society and by training them. However, I also believe that these kind of systems will only go towards a stage of cognition like a dog, right? I don't think that they will immediately, at least, go to cognition of humans.
But dogs also have inhibition, right?
Yeah, and that is something that you need to somehow train them, teach them, not necessarily train them, but teach them.
Thank you. Maybe I can round it off with an Elixir question.
Yeah.
Because I saw you, first you used Windows, which is amazing, just to get it run there. Then you used Livebook, you used Gen servers, then you popped up the Observer, right? And then you showed that you use ETS tables, right?
Yeah.
And before you mentioned like you worked like 3 months on this. And I know
a few months
on it. And I know like a lot of, like sometimes we have this here where like we pop up the Observer and then people see that the first time. So how did you get into Elixir? How did you learn so fast, so much about it and get so deep into it? Maybe you want to share a bit about that?
So Elixir was, first of all, my first functional programming language. But I'm completely self-taught, right? I have no formal education in any sort of computer science, so I just sat down and decided that I want to do this in Elixir now. And then I asked ChatGPT, how can I learn Elixir?
Yeah.
And then I just started implementing it, right? And I mean, this is version probably 200 by now, because I learned and learned and learned and realized that this is complete mess over here. I should rewrite this. But I found Elixir just to be extremely easy to learn. It was really within weeks, I was at a point where I didn't need much documentation anymore or anything like that. It just came flying. What really, really took some time was getting the knot of object-oriented programming out of my head, you know, and relieve me from that kind of, because it was so ingrained in me. And it really took effort, and it still does. Like even today, I have been working with Elixir now, maybe let it be a year now, not a year yet, I believe, that I've been working on that, maybe 9 months, 10 months. And I'm still struggling with that, but generally speaking, you know, if you have a project and you have LLMs that can give you information, just don't let the LLM build the whole thing itself, you know, don't just tell Claude a prompt and let it build it. Just do it yourself and, you know, use ChatGPT or Claude or Copilot or whatever as a resource. You know, I think you can learn a language like Elixir very, very quickly. I tried Erlang first. I utterly failed, and the syntax was just messing with my head. And then I moved very, very quickly over to Elixir.
Makes sense to me, but maybe Dan wants to interview later about that.
But I only tried it for a few days and realized that this syntax is just not for me. Others probably love it, I guess. I don't. I was very happy with Elixir then. Yeah.
Amazing. With that, thank you very much, Leonard.
Yeah, thank you very much.
And let's take a 5 minutes break, and then we're just going to dive into the next one. But let's get like, I wanted to say zoom out, but that's not what I meant. I meant like extract, take a drink, relax a bit, and then we come back here. And of course, feel free to ask Leonard more questions about his project. to have Lukas joining us here in a minute, so we can get back to the main program before we go to the socializing. Also, if still something comes to mind and you want to share, we have like the first entry on the lightning talks. Feel free to go over there and write down your name or your topic that comes to mind. Think of something you learned about Elixir in 2025, if you want to round up that year, and share that with us. With that said, Lukas, you want to tell us more about privacy by design?
Yeah, happy to get started. Let me just steal this here.
Yeah, please. This is actually the HDMI, and this is the power.
Okay, just need the HDMI.
You can have both.
Cool. Yeah, hi everyone. I sometimes get asked like, how do I get the idea from my talks and stuff? So I don't know, right? Sometimes I get asked by Chris, hey, do you want to do your talk? That was part of the Unconference last year in December, and I said, yeah, okay, I want to do it. So it's often as simple as that somebody asks me and I do it. I hope it's still going to be interesting for you. So if you have been here in December, I've been conversing about this, and there was an open panel in which we had a very, very interesting and good discussion about this topic. And so now I put it into a talk and made some slides for it and try to convey the idea that privacy by design is actually integratable and it's not hard and it's something that you should and can do, and give you some reasoning about it. Just for why am I doing this, because I realized in the slides I'm not even saying for whom and for why. One of my clients, Myosotis from Berlin here, they are running a digital tool, FormFix, which we built a form builder for, or I built a form builder for, and this form builder takes data for the Sozialhilfe-Pflegeantrag, which is a German thing. It's basically 1 million questions that you have to fill out at the end of your life so you get some financial support in order to be taken into elderly care home. Now, this is a real problem, and it is real people's data, and the data that is being collected there also warrants some proper encryption, because it's financial data, it's medical data, it's personal identifiable data, and that's why we built the system from the beginning and from the ground up to be properly encrypted. And how this was done should be the content of the talk today. So yeah, welcome to my talk, Privacy by Design. Yeah, actually it's January 15th, you can see that I had the old data there. Let's talk a little bit about data privacy, a little bit about Elixir and Erlang, and a little bit about encryption, so that you can take some good away from it and actually apply that in your own practice. Data privacy, right? So the GDPR generally divides these responsibilities into 3 roles. One is the so-called data subject. Another is the so-called data processor. And the third is the data controller. Each one of these have different descriptions and responsibilities and obligations. So the data subject is usually the customer whose data is being processed. And it basically, they basically have the right to information, correction, and deletion of their data. That's basically what it means in a nutshell. Then the data controller is, for example, your company that collects personal data on behalf of their customers. And their obligation is to ensure the lawful processing of the data. And that's a very interesting middle position, because usually the data controller, which I showed here, they hand this over to the data processor, which is, for example, your hosting provider that stores and processes the data. And they have the obligation to actually just comply and protect the data according to the instructions and constraints that the controller sets up for the data. So basically, you have this trifecta of 3 roles that make up data privacy. But what I find quite problematic in this picture of the 3 roles, usually one role is missing, and that's the adversary, which is my little triangle guy up there, which will accompany us throughout the presentation. So that brings me to the topic of data security, because data security is the practice of ensuring that the personal data, the data of your customers, for example, is only accessible to the parties that are actually explicitly authorized and to no one else. So now this poses a whole different challenge, because the adversary, in the whole privacy discussion, the adversary never plays a role. So let's make this guy play a little role so we have an understanding how to actually model the data, what boundaries to draw, and how to actually integrate and implement something like this correctly. So if we, okay, I have to wait until the, okay, wait, so the subject trusts, so in this new model that I propose for data security, right, which I think should be a better way of viewing it, right? So I think the subject trusts the data is handled according to the declared purpose and not exposed by any design flaws or operational failures, right? I think that's a much better description of what the data subject is, as opposed to the official lawful statement of what a data subject is. And in this light, you can put the subject and the adversary in relation, right? And then you can see the adversary maybe wants to extrapolate, extra-filtrate data from the subject, or actually gain their identity or whatever, and do something bad. And now the controller then has the role to define what guarantees does the data need to be processed, and then also assess the requirements and the acceptable risk. That's again, if you view it from that angle, you put the controller and the adversary in a relation, and the risk management becomes the major thing that the data controller has to do. And then basically the processor is then responsible for how the data is protected in practice, basically by using encryption, access control, isolation, and secure storage. Again, you put those two in relation, and you get a much better picture of what you actually should do and what you should act on. Now, moving on, let's actually take these things that we learned from privacy versus security and in the relation to an adversary, and that's the things I care about when I design a system that has these things in mind. Not the privacy and the law and stuff like this. I actually try to care about these things more than the other thing. So if we design a system, and that's your general web application, I see security as not as a single mechanism that you put in front, like you say, we have Cloudflare, cool, everything is secure now. Or we use HTTPS, everything is secure now, right? You actually should look at it like a layered response to the different capabilities of your adversaries. And an adversary in this case might just come from the internet. And so you start thinking about this. As I said, we want to put something in front of our system. That's the classical way of how systems are being secured, right? You try to prevent access from the outside to the inside. Then you think about, oh, damn it, what if the adversary actually gets access to the application or something else, right? Then you try to think about things that you can secure the system in a way that if the adversary is actually behind the keyboard and pushing code, or if the adversary is behind another keyboard and pushing code to the node packet manager, yeah, that's stuff you have to worry about in different ways, and you have to implement different security mechanisms. Or what if the adversary sits at your hosting provider and just has access to the disk of your data storage layer? You'll have different things to worry about, and you have to implement different security practices. So overall, same for the object storage, what do you do about that? If somebody is has access to the actual servers that host your S3 data, same problem. So you try to think about it like this. Did you try to put a lock and some mechanisms on each of these boundaries and each of these sections, right? And then you kind of try to look at it like this to limit the damage that can be done if the adversary has one capability or exercises two of his three capabilities. Usually, there is no 100% guarantee in security, so if an adversary is determined enough to have all capabilities in the world, then you're usually, nothing will work to stop them. So just see it like this. Access control just prevents unauthorized use. Then you have a second tool, the encryption, which then tries to limit the damage when access control fails. And you try to combine these two mechanisms in a clever way so that each of these boundaries tries to protect the other boundary. So for example, you have the data storage layer that you only put encrypted data to, but your keys are stored somewhere else. So you have a system layer in between, and you make sure that no keys are being locked somewhere or something, or they don't stay in memory, and therefore basically each boundary is isolated. And so you try to make these boundaries work for you. Right, so that's encryption. And then secure storage, in a way, it doesn't mean that it needs to be hard to access. It actually means, for me, and that's something I like a lot in the system design, is that the storage is useless without the correct cryptographic context. And that really frees you in a big way, because if you encrypt the data correctly, then somebody can have your database, but they can do nothing with it if they don't have the right keys to decrypt it. And if you do that cleverly, again, storing the keys not in the same database, but in a different one, and the root master key is maybe in yet another system, this allows you to do these kinds of boundaries, and then potentially you could host your database in the open, right? And you don't care about the authentication mechanisms that might be broken. The data is encrypted in a secured way, and you have a nice boundary around that. Okay. Let's come to the next topic that was widely discussed in December. This is wrapped key encryption. It's a really nice way of kind of creating an encryption scheme that tries to split the trust across system boundaries. So as I said, you don't want to put all your eggs in one basket, like just have one server with all the databases and all the keys and everything on that server. You try to create system boundaries so that the root key that you encrypt your keys with is living with some provider, then your keys that you encrypt your data keys with are living in this database, and that the data keys that are encrypting your data live in yet another database. So basically it's all a big onion, and you try to peel it from the outside in, and each layer of the onion is like a different provider that you entrust your encryption keys with. And that's basically in a nutshell, what wrapped key encryption is. So, as I said, the adversary might have access to your cloud provider and not your application key management system or your storage. The adversary might have access to both your cloud provider and your application key management service, but doesn't have access to the storage. So again, it doesn't work. And if the adversary is determined enough, they might have access to everything, and then of course, the whole thing breaks, but there's no guarantee for 100% security. You're just trying to make it very, very hard to exercise all the capabilities that an adversary might have. Again, wrapped key encryption as a function, you can look at it like this, that your root master key is the one that's, for example, used in a KMS that's provided to you by a cloud provider. Your key encryption key is then living in your own KMS system. Your data encryption key is then encrypting your data, which is then stored somewhere else. And so you can see these boundaries work really nicely. And these three, I think, is a very good basic set for a strong privacy-first, security-first encryption system, which I will then also show you a little bit in practice. To the topic of encryption algorithms, which ones to choose and which ones to build yourself, well, just don't build yourself. Don't build one yourself. Leave that up to the cryptographic experts. They are quite cool people. They know their stuff. And so I chose the ASGCM, which is quite nice. It can encrypt data, and also with an additional authenticated data part, which comes in quite handy. And yeah, if you don't reuse the same key, basically it's a very secure encryption algorithm. That's the gist. You can basically use ChatGPT to give you a good list of encryption algorithms, and today you can also let ChatGPT explain them to you. So if you're ever wondering what all these acronyms mean, what their traits are, what their benefits and drawbacks are, you can now get a really good overview. And so CBC is another one that comes up quite often. It's quite nice as well, but it has no built-in integrity checks, so you don't know if the data was tampered with. And so we actually preferred GCM because then we even have a tamper-proof check in there, which is quite nice for the case that we have. So we are entrusted with a lot of like high-profile data, and so we also want to make sure that no one tampered with that data, and that's GCM that gives us this capability. And now jumping on to something more interesting, the integration. So what did I use to implement my crypto? I used crypto. now I look a little bit like a guy who tries to sell you the next financial scam. But no, this is just the Erlang standard library. Thank you, I guess. Really nice. It's well built. Gives you a lot of, I would say, lowish level encryption primitives to work with. Then the second part I will show you in code is the KMS crypto module that I wrote in Elixir. I can't call this an implementation because, again, this is just integration. And the idea here is really, I want to build one module where all my crypto stuff lives so that it can be audited very easily, and then also it can be made very clear to where the crypto is happening, which libraries are in use, and there's virtually zero or just one dependency to track, which is the Erlang OTP, and I'm fine with that. And then another thing, a gem that I found during my work. So we are dealing with form data, and what is very common in forms, especially in Germany, you have to apply additional documentation to your forms in the form of PDFs and images and scans and whatnot. So we had to deal with uploads, which is a bit of a mess when you want to do encryption first, because either you entrust the encryption system with your cloud provider, which again would be against the wrapped key encryption scheme and the isolation of systems that I showed before. So we had to roll our own, but luckily, thank you, Phoenix, for that. There is behavior that we can leverage to make this relatively easy, which I will also show you. Okay, so before I close, let's actually jump into the code and show you some nice stuff that I found really interesting when implementing this. So first, the simplicity of implementing a crypto module for your application. So as I said, you kind of try to make sure that you understand the algorithm that you're trying to use. Then you maybe go to your next provider, for example, the Erlang standard library, to actually get an implementation of that algorithm. And then it's time to go in the integration part, and where you basically write a little bit of your own code to make up your API and how to actually use that with your own code. And I found some really cool gems in doing that. So I wasn't sure which ciphers to support. These numbers, 128, 192, and 256, are basically sizes, so you can make it a bit more or less secure by choosing a higher size. But then, again, when integrating your own crypto, a lot can go wrong. For example, if you choose the wrong initialization vector size, you can screw yourself really badly. But kudos to the crypto standard library implementers. They implemented this cipher info function call, where you can basically just put the name of the cipher that you're using in, and you get a nice little response that tells you which IV size to use, for example, and so on. So you can hardly get wrong with that, which is really, really nice. I liked it a lot. So for example, if I want to generate a key, that's the canonical way of generating a secure key. And also then if you have the key sizes that are recommended and you don't want to go below that threshold, you can just basically pattern match on the key size that you have provided in your generate key function to make it a little bit more secure and harder to break from the outside or to misuse in a way. Then you have your encryption function for AES GCM. You have a plain text, the data key comes in, and your AAD. And there I basically just follow the recommended standard integration for that. I get the data key, decode that, get myself an IV based on the cipher IV length. And for that, I'm just using my little lookup table from this crypto info call. So whenever you're wondering which IV length should I choose, don't wonder, just if the standard library that you're using provides it, then you just take that information and pass it along, which makes this problem actually quite nice or easy to deal with. And so I'm getting my ciphertext here, put it all together, and base64 encode that, and that's my encrypted data. Decrypting goes the other way around, and then here's a little helper function, a private one, to actually decode the key and get the right key size out of that. So basically even with decoding the key, I can just check if the key is the right size and so on, so I don't make a mistake there. So that's that. And last but not least, this other gem I found, this behavior of an upload writer. This really saved my day because I was like, damn it, now I have to stream encrypt the data while it's flowing through my system and so on. And how do I do that? Oh shit, I need to write my own upload mechanism and maybe do a controller that does it outside of the live view. But no, it actually works really easily. You can basically have a live view upload writer implementation that you provide yourself. That's really cool because in the end, if I follow the behavior implementation, I get myself some initialization code. Then the meta, that is the return value of a finished upload, is basically an upload reference in which I have the data key, where it was uploaded to, and so on. So all of the necessary information, which then gets again encrypted and stored in the database. And the interesting part is writing the chunks and actually uploading that thing. So this implementation has one particular problem. Maybe you find it and can name it. I would be very interested if you actually find that. I found it, but let's go through it real quick. So we're getting these chunks, and what I'm doing is I'm sending that to my little task, and the task then just updates, like the outside updates the state. I'm handing this over to my task, and whenever the task is done, it waits until the task has finished sending to my object storage, and then in the end terminates this child, and then it's done. And then there is some private methods for handling streaming to object storage and so on. And where does it start? Here. And when in the initialization method, we use a no-linked asynchronous task supervisor to actually start the task of pushing the data to the object storage. And with my crypto-stream implementation, I can basically use a stream resource to asynchronously receive the data as the client is sending it, encrypting each chunk, piping that into my crypto stream, and then passing that along to the upload stream directly. So my whole application server is hopefully not blowing up in memory when somebody uploads a 1 gigabyte file. But there's one problem with that implementation. Maybe you find it, or maybe you found it, I don't know. Any guesses?
Something with the async task being a zombie, or like staying alive, or
No. Something very primitive in Erlang and Elixir. How does the message passing work? There is no back pressure, so that's a real big problem I found. So whenever the upload side is really slow, and the sending to the object storage side is really, really slow, and the upload is actually faster. So let's say the client that's uploading to me is really fast, but the object storage I'm writing to is really slow. It will basically be the whole file in memory again. Damn it, I thought it was a good implementation, but then it's actually not so good. What is the rescue? It's gen stage. Ideally, you would use a gen stage in here, which has active back pressure, so you can hold on the client and say, don't send me more data, only send me more data when the next chunk is ready to be processed. So you will get a memory stable model. This is not memory stable, I found, but it's a good first implementation, I think. So, anyways, but the key is, if you ever find yourself stuck in an upload problem and you need to write a custom thing in between your upload, it's actually, I don't know how many lines this is. This is, less than 200 lines of Elixir code. And yeah, I was pondering many days about this, and then I found the actual behavior, and I was like, cool, that's it, cool.
And you went, just to understand, you went from the normal live upload to this because you didn't want to have the temporary file on this? Was that the...
Yeah, I mean, I don't want the stuff to be stored anywhere. Basically, I just want this to go to the object storage directly. I want it to be encrypted, and that's all I wanted. I didn't want like file and then take the file somewhere else. And if I stream, then I want to stream, and so that's what I do. And yeah, so this gem, I didn't know it existed until a couple months ago or so, and then I wanted to share it as well. So today I learned, and then of course another thing that I really like is the crypto Erlang standard library. Great documentation, really well implemented. So if you ever are in need of such a thing, go for it. That's cool. So then, thank you. Please leave a like, comment, subscribe. Enjoy your encrypted soup. Here is what I do for a living. Here is what I wrote as an AI project. And it's a little thing you can contact me about. Yeah, and that's me. Thank you.
Thank you so much. Do we have some questions here on privacy? Dan?
Any thoughts about, so there were two things. One was, is there a reason why you wouldn't write the cryptographic stream to a file instead of backing up to the client before you send it to an object store?
Yeah, I don't want bloat anywhere. So I don't want bloat in my memory, and I don't want bloat on my disk. And so we're running a single application server for the application. And so if we would receive many uploads, we would have the same problem as with memory. We would have to have a space to store it somewhere as an intermediate storage. And it has to be stored in object storage anyways. So the final destination is not the disk. So that's why we say, let's just stream it through. And that is actually, yeah, the rationale behind it, yeah.
So the second question I have is, what about key rotation?
Yeah, in wrapped key encryption, you can use one really nifty thing is that, so your most outside key, the root master key, that's the one that's rotating the most slow. You would usually rotate it for setting up a new environment or on a, let's say, semi-regular basis, that's usually fine. The key encryption keys are rotated usually in our case, on a case-by-case basis, because every case that comes gets its own key encryption key. And then the cases are not that long-lived that we have to rotate it, actually. It's just fine to have one key encryption key per case. And what does rotate really often is the data encryption key, because we rotate it with every write that we receive to that field. So we receive the user enters some data in a field, and that triggers an autosave, and every save on each field actually derives a new data encryption key from the key encryption key. And that rotates the whole thing really often. And so if, there's actually nothing more to rotate or worry about, except, as I said, the outmost key should be rotated at least somewhat regularly. And the key encryption keys, the lifetime of a case is not like super long. We close those cases within 2.5 months. So, and then they're thrown away, and then the data is also invalidated. Yeah. So it's kind of like, I would say, almost not necessary to rotate them, because we don't store the data for much longer than. Yeah.
Can I follow up?
Yeah, please.
So where do you store which key was used?
It's a wrapped scheme. So at each stage, I know which key to actually query and use. And the data encryption key is just stored along with the data. But you can't, it's an encrypted data encryption key. And so you can store it alongside the data. So you just know that the encrypted data encryption key is just next to the data. And if you would get the database, you would still be able to do nothing with it, because you have to first to decrypt the data encryption key to get to the data that is encrypted with the data encryption key. And then, you can see it as a pyramid, yeah. Yeah, so I see onions because I want to make the adversary cry. But yeah, I also cry sometimes, yeah.
So
that's the answer.
So the data key has to have some indication of which next level key it was encrypted with?
No, it doesn't. No, it's just basically 3 levels of keys that I use. And they're bound to each object in the database, and a field is bound to the data encryption key, a case is bound to the key encryption key, and the overall system is bound to the root, the master encryption key, yeah. That's fine. Critics are welcome, please.
So just to understand the onion, so
Yeah.
if I own one layer of the onion which is in the middle, like the app server, for example, I wouldn't be able, like if I have a remote shell open to your app server and say I'm in the beam, I wouldn't be able to query a random piece of data from the database because I'm missing the client key, or?
So, wait, it probably doesn't work now. But okay, I want to just pull up the picture again because it's a bit easier to explain inside. But yeah, so if you get remote execution on our application server, you would be able, with enough time, to sniff out the passphrases of the users that they use to decrypt their cases. We don't know the passphrases that the users have. We generate the passphrases once, they're then volatile in memory, and then we leave them. And they are in memory while somebody has a session with us. And then they leave our memory again. So theoretically, yes, you could, with enough determination, get remote execution, then wait long enough and sniff out stuff from our memory. Yes, that's a big problem that we still have. You only get around this by doing end-to-end encryption, which we cannot do. But it's possible to, that's maybe a very interesting follow-up topic. Browsers nowadays have really strong crypto primitives. So you could actually do end-to-end encryption relatively easily. Yeah? It would be possible. So it's not impossible. What we chose against, because we have not only the end user, we also have a concierge working for the company that needs access to this data. So it's like, it's going to be really difficult to do this with end-to-end encryption. Yeah.
Milan.
How often your clients lose their passphrase?
Yeah, that's a really good point. It actually is quite the way we work around this is if somebody creates a case, maybe let's do it. I don't know if I have it local here. No, it's not running. Okay, whatever. Yeah, you generate the passphrase here, right? And you get the passphrase, and then you do some link, and then you have a checkbox which reads, I have saved the passphrase on a secure place. And you check that, and only then you get the final link to actually use it. And I deem this step necessary because, yeah, it actually happens. But the funny thing is with responsibility and data subjects, right? There is a certain point and a boundary where you can say this is no longer my responsibility. And that's actually fine with the passphrases, because if they lose the passphrase, that's their responsibility. If they are hacked with their computer and the passphrase is leaked, it's their responsibility. We only have to take care of our own system boundary. And so it's fine to generate the passphrase. We have to make sure it's a secure generation. It's probably, yeah, an acceptable problem to have. We have no logins, we have no users, we have no long-lived sessions, nothing like this. We only have encryption that basically secures everything. So it's actually a very neat way to build a web application. We don't, no emails, no background job that sent email, forgotten, blah, blah. We just, that's it, yeah. The user has some responsibility.
I have a question for that. It's actually one of my favorite questions that comes up. And like every time you do like write a module like this, and you have like some key that you pass around in functions, like what happens? When I write code, I write a lot of bugs. So what happens usually to me is that of course like it crashes in the middle of that, and then unfortunately like Erlang is awesome to debug, but then the crash dump, which ends up in your logs, has like the private key in binary format.
Yeah.
And how did you deal with that problem? What is like the trick?
Well, we run in containers. And if something crashes, the container is wiped and restarted.
And the logs?
And the logs, if the crashes are in the logs, and we would leak the key, yeah, that would still be a leak. So I did take care that all the structs I use and all the actor schemas I use have the flag of, yeah, I forgot to actually show this, but there's a flag you can set on actor schemas that something should be redacted. And there is a thing that on structs you can do, and then on ETS tables you can do the same. You can make private ETS tables for certain things. So that's some Erlang level things you can set, and you should. I hope I did it on all the cases, but that is always a good reminder I should check. Yeah, because this is obviously a problem, right? If you leak the passphrase, if you leak links or anything, yeah.
Yeah, this is
It's a
awesome.
huge problem, yeah. And I'm trying to take care of it. But in the end, I think it's also a problem that it's still contained into our system. We don't send the crash dump. Like, we don't have a Java thing where like somebody could connect to the debugging port and and so on, right? We don't do that, and so.
Yeah, makes sense. But, yeah. I think it's common from often you have like some kind of log collector connected, right? Because you want to actually debug your system and have monitors in place, and often it's standard that your logs actually stream into some monitoring system. And now,
Right, they do, yeah.
it's like way too easy. Suddenly you have like these private keys in your logging system. And
Well, I hope, this doesn't happen, yeah. That's a real big trouble, because I just set up the Grafana monitoring that we have. It's all hosted in our premises, so that's the positive side of it. So if they would leak to our own systems. There's not a third-party provider like Papertrail or some other service that we use for logging. But the retention and storage of this actually could compromise the system. Yeah, it's true. Yeah.
Cool, awesome. Yeah, but that's always something I'm curious about. So if you guys have experience with that.
This is just a side question, but you said on-premise, and so the whole presentation is this is a showcase on the cloud somehow.
It is, yeah.
But we agree this is also something you would recommend, obviously, to have an on-premise system. So to increase the security.
You got to assess the risk. So I'm not a cloud defender or a proponent. So I think I'm in between. I would say wherever you are in your decision process, just assess the risk that you bind to the partnership that you go with your data processor, right? So I think that's the main thing you have to do and take care of when you are the controller, right? So that's the situation. You have to kind of negotiate that with yourself and your own risk assessment, right? We use a German cloud provider for what we do, and we assessed it as being not as a big risk as, let's say, a US Act cloud provider, where we have a problem with a third country like the US accessing the data of our customers, because by law they can do that. So there's that, right? So we chose for a German one. Obviously, if you go on premise, you have all the control. That's really a good thing, but also you have some other problems because you need to keep your systems up to date and so on. So it's a balance, right? It's nothing is for free in this case, yeah.
Thank you so much, Lukas.
Yeah, thank you.
That was great. Great dive into privacy. There's one thing, Dan, maybe you know that. Like, I think the privacy and like the reducting stuff automatically, I think is generally a topic. I know in Erlang actually has this deep feature to mark a process as sensitive.
Yeah, and you cannot extract the state from a process that's marked that way.
Exactly. So even if that process then crashes, like it will not produce like a crash dump. But not always you can control that. Like especially if you're running like in like a live view environment or something, you might be too deep in the stack to make that properly. So it's always interesting what other mechanisms, like on logging, on Ecto, you have other ways to prevent that. So that was my super lightning talk here that I just injected. But let's go with EU OSS Consultation.
Yes, I just need a laptop.
Yeah, let me give me my laptop. And
So prepared.
no worries.
It's really a lightning talk. About 2 minutes of your time. Last for about 30 minutes of your time. I just need a web browser.
Okay. Let's see if that.
Audio, of course.
Oh.
Is it going to be fine if it's split, or you wanted to mirror it? Do you want to change or navigate, or you just want to show something?
I just need to share a web page, so whatever's easiest.
It's like this, and then just enter some URL.
Cool.
And try that. Just you have to watch it that when you.
All right, no problem. Hi, I'm Andrew. I just wanted to share something that I did this week, which is tangentially Elixir related, and actually bookends Dan's talk at the start. And this is that there's a chance for all of us to do a little bit of participation in a bit of EU democracy. Currently, there's a consultation happening until the 6th of February about open source software and how it's used in the EU and how the EU Commission can support open source ecosystems. And so I really urge you to take 20 to 30 minutes to fill out this feedback. You can be like, if you are an owner of a company, That's, you can put your company name there and it's a bit of a stronger representation, but also you're very welcome to do this as individuals. When I did it this week, there were 261 submissions. So someone, I think, or they're going to feed it into an AI machine, but hopefully someone is going to read these things. And I just wanted to quickly show you, because it's EU, it's a little bit bureaucratic, it's a little bit hard to fill it out. I really wish I could go in and literally fix things like make the text field bigger. Also, I'll tell you later, but when you're doing it, make sure to copy and paste it before you put submit in case your session's timed out. Those kind of problems I would love to be able to fix with the EU platforms. So easy enough to find it. EU Commission, am I typing this? OSS Consultation. Then, okay, second link here. Is your computer black and white? And so the trick is, this is the, no, that's the wrong, no, got the wrong link. What search engine? I need Bing, I think. Wait, maybe just change to, because that actually came up first time when I did it just now. No.
VAT one-stop shop.
No, I don't want that at all. Okay, and then I'm going to go to my... Oh, you have a German keyboard.
Wait, I have a German keyboard.
That's why nothing makes sense. I also can't see. Okay, I retweeted it on Mastodon, so the link should be right here. Or not? There we go. This is to some website, but they have the link at the bottom. Google through, is great. So, European Open Digital Ecosystems. It's a call for evidence, and what you need to do is download that PDF. And this actually, ignore all this. This is blah, blah, blah. We don't care. What they want, because obviously if you just write some random stuff in the feedback form, they're not going to be super interested. But they have a key bunch of questions under the colored heading. Things like, what are the strengths and weaknesses of the EU open source sector? What are the main barriers to adoption? What's the added value of open source for the public and private sectors? So, for example, my feedback included things talking about supporting package management ecosystems, super important, supply chain security. We know the EU is already interested in that with software bill of materials stuff coming up. And then to actually fill it out, so this is the area, the questions you can mention, can answer, and then to actually do the feedback is another link somewhere on this page. Oh, there you go. No, give feedback. Yeah. Then you do have to log in to the Have Your Say platform. And I'm afraid if you're not a European citizen, you can't do this. There was a country selector, and it does say, I think it was only listing European countries, but maybe I'm wrong about that. You can log in with your EID. If anyone wants to try the Ausweis 2 app, that's a lot of fun to try and register your account. But really, it's not too hard to do. 20 to 30 minutes of your time, and most of that is just getting through the systems and making it work. And you can use an LLM to generate your feedback if you really want. But anyway, I urge you to do it. It's a rare chance to actually have a tiny bit of direct influence on our political system here in the EU and support OSS, which we will rely on. Okay.
Thank you so much.
Thank you. Yeah.
Can you share the exact link on the Slack of Elixir and the Discord that we have? That would be
Sure.
really nice.
Yeah.
Then we can all follow up there.
Yeah.
Cool.
Yeah.
You said it's only for EU citizens. I already wrote the thing, but I didn't send it. It's not an issue we can find on European here. But I read there is some comments. I don't remember which page, but there is a very good comment from the CEO of Inkscape. It's a very touching thingy. So I'm wondering.
Okay.
There is a comment section.
Yes, you can.
Is it submission, or is it actually a
There's down here is the
Feedback and statistics, right?
oh no, non-EU citizen. Oh no, you can be no, non-EU citizens are allowed. So I thought the country selector was just because when I submit it, I have to say who I am, and it includes my country or where my company is registered and the company ID and things like that. But no, you can. I don't know if they treat it any differently. I can't tell you that. Maybe they're like, yeah, if you don't live here, then they maybe that goes in a different pile. But no, anyone can give feedback.
All feedbacks and statistics is actually the real feedback.
Yeah.
Being sent already.
Yeah, it's a public, very much a public consultation process. So you can. I think there might be an option before you submit to whether you want it anonymous or not, but.
It is worthwhile to look at the feedback that's been submitted. When I first looked at this page, it was about 500 entries, so I mean that's obviously a lot. A lot of people are saying very similar things, and I would say that if you're going to submit something, try to say something that everyone else is not saying.
Mm-hmm.
Try to think about the problem from either a personal perspective, professional perspective, not just making the sort of obvious statements about how open source needs to be sustainable.
Yeah.
Because they already know that. But there may be things that you, I don't know, when you read through these, that seed some sort of thought that you don't find.
Yeah.
But with this many entries, like you're not going to sit there. You could sit there for a couple of days and read through it all.
Yes, I mean, obviously professional organizations are also involved in this feedback. Yeah, try to make things concrete, I would say, and practical, like completely banning the use of proprietary file formats, I see on that one. I don't know if that's gonna fly, but, and a lot of it, of course, in the current political climate is distancing ourselves from the US.
So there are a few interesting topics that cross into this, and one is, can you really have all the benefits of open source software if you don't have also open hardware? Because a lot of the things that throttle what we can and can't do are proprietary hardware interfaces.
Mm-hmm.
So there are a lot of sort of tangents that you could potentially follow that really have an impact on open source and its sustainability.
Cool. Anything else? Nope. Thank you very much.
Thanks so much. And that concludes the official part of this. So thank you all for joining. Next month, we're going to meet again on the 12th of February at Meantrix. That's a different office, a new place we haven't been before. And we already got 2 talks set up. So we're going to schedule the meetup tomorrow, probably. And then hopefully see you all there. And if you are happy to give more talks in the future, please submit. And we're going to have March and the month afterwards for more talks. Thank you. Anything to add, Chris? And otherwise, if you see me or Milad or Chris and you have some feedback, just shoot out to us. And we're organizing this every month. And I'm happy to take every and all feedback. So thanks, guys.
Cool. Oh.
Don't say